In this lecture we will continue our discussion on data management tools for the grid. So in this lecture we'll discuss the storage information system, give an overview of the different identifiers that can be referred to when dealing with data, and show how to include these files in your JDL so they can be referred to when scheduling a job, and we'll show you how to manage large files. In this picture we see a comparison for the information system backends regarding the computation and storage resources. Files which are stored on the grid are registered at least once, but usually in two places. The backend storage system, and this is the place where the data actually resides, so this is where the files are physically stored. Most backend storage systems can be accessed using the Storage Resource Manager, so the SRM protocol. And the other place where you can store information is the logical file catalog we've seen in the previous lecture. This catalog is intended to provide users with an easy to use logical file name, or LFN, and it allows for the use of replicas across different backend storage systems. And of course you could also just do that using the SRM protocol, but then there's no overall governing entity which lists all the replicas automatically for you. So the decoupling between the backend storage and the LFC is not very tight. It is possible to rename a file in the backend storage system without the LFC knowing about it, and this results in the disappearance of a file in the LFC. You can also delete a file in the LFC while keeping the file stored on the backend storage system. In this case you delete the entry in the database, but keep the file on the storage itself, so the file still resides on your SRM. In most cases this is called dark storage. It is important to keep this in mind. You should choose to either do everything for a particular file using the LFC or only use the SRM commands directly. And what these commands are we'll see in the lecture to come. Files in the grid can be referred to by different names. So you have grid unique identifiers, or GUID, a logical file name, or LFN, a storage URL, or so SURL, and transport URL. While the GUIDs and LFNs identify a file irrespective of its location, the URLs contain information about where a physical replica is stored and how it can be accessed. There is only one GUID in the LFC for one file regardless of how many replicas of the file exist, and for each replica there is exactly one SURL. So for each file that you store on a separate SRM you get one of these SURLs. So we can refer to the grid files in several ways. So the GUID, the SURL and the LFN. The grid unique identifier, which identifies a file uniquely, is of the form GUID and then a 36-byte unique string. So an example is given on the slide. The logical file name, which is the human readable form, always has the form LFN and then a particular directory structure. In the case of the LCG file catalog, the LFN are organized in hierarchical directory-like structure and usually have the following format. So you'll start with the protocol, LFN, grid, list the VO, have a number of subdirectories, and then a file name. The storage URL, also known as the physical file name, or PFN, which identifies a replica in the SE, is generally of the form SRM with the SRM hostname and the port when it differs from the standard port, and then again a list of subdirectories. And these usually are also arranged for different implementations of the SRM protocol, so Dcache has its own structure and DPM also has its own structure. You can look these up on the websites of the different implementations. The transport URL, which is a valid uniform resource identifier with the necessary information to access a file in an SE, has the following form. So you have the protocol, your hostname, port, and again a path. And again there's an example on the slide. So you can also specify your data requirements in your JDL. What this tries to take care of is to schedule your jobs near a computing element that can perform your job. So the presence of the data requirement attribute causes the job to run on a CE which is next to the SE, so the storage element, where the requested file is stored. Note that this attribute doesn't perform the actual copy of the file from the SE to the worker node, And as what we see, this has to be done by the user. This case describes the data requirement attribute in your job description file. So as you can see on the screen, we have this JDL ready. This attribute is a list of class adds representing the data requirements for the job. Each class add has to contain 3 attributes. The input data, which is a list of input files needed by the job. The data catalog, which basically specifies the type of data catalog, which is needed by the grid middleware. And this is needed in order to resolve logical file names to physical file names. And there's the data catalog type, the address, the URL of the data catalog, if this is not the VO default one. Okay, we've already uploaded a test.txt file to the grid with the same commands we demonstrated in the previous lecture. So let's take a look at how we can input this in the JDL. So first let's take a look at what we're going to do. We have some exports to define to which LC host to connect and some other specification that we need, and then we just do the LCGCP, so we do a copy from the grid to the local file system. Of course we use a tutor VO, and the S1 that you see in this line is actually the first argument of the script, and then we just have the local file. We do a ls on, and then we print the content. Right, we'll take a look at the JDL. Okay, so this should be familiar by now. So we have the executable, which is the standard shell, and then we provide as an argument the script that we're going to send with it and the file that we want to run on. So this will be the input. And then we also specify the data requirements, which will be handled by the GSFTP protocol, and we specify all the locations of where these files are stored. Right. You can just use the normal glide WMS job submit command to do the scheduling for us, and this should all be familiar by now. And just specify where the job IDs need to be stored in the JDL itself. Okay, and the job has been scheduled, or at least it has been sent to the WMS. We have the identifier. We can just take a look at how things are going. Alright, it's done. So we can now take a look at what the outputs are. Right, just a normal output command. We want to retrieve the data to the current directory. And we can just copy the identifier to retrieve the output sandbox. This is where the data is located. And we can just take a look at the output file. And there you go. That's it. Okay, let's take a look at the SRM input. So if your VO does not support the LFC catalog, then your job should contact the SE directly using the SRM or GSIFTP path of your data instead of the LFN. So we're going to take a look at how to do that. And again, note that this in itself is not enough for the script to use that file. It still needs to be copied to the worker node when the job lands. Right, so we have here the SRM location. And again, we see that we can copy the file back to the worker node using LCGCP. Now we take a look at the JDL as well. And here you see that we specified the SRM address of the data. So that's the remaining part. Okay. and the protocol still stays the same. Now we can just submit it. Okay, so again, job IDs and the JDL, and submit it to the grid. And here we have the identifier again that we can use to check the status. There we go. It's done. And we can just show the standard output. And it's basically the same procedure as we've seen before. This is the file listing. And it basically works the same as all the other examples that we've shown before, but now just with the data transfer in it. So, to provide a short summary, the input sandbox and output sandbox should only be used for small amounts of data. So for sending over your scripts and some minor inputs or maybe some application code, it's fine. But for everything really data related, you should be taking the data to the SRMs or to one of these storage elements and retrieving the data once you need it. And if you're working with huge amounts of data, you should make sure that it is available on the SEs of one of the clusters that you're going to run on. And you can use the JDLs, but there are also some other methods to schedule the job that you want to run near the data that you're going to use for that particular job. So you can use the JDL file to specify this. There's also other options that you can have. We see these options later in the course. You will need to specify which of the main SEs you want to use, what the default is, and you can specify the data access protocols that you need to use for transferring the data from the SE back to the location where you need them on the worker node.